Hello, my name is Sean Conley. I'm the State Soybean Small Grain Specialist at the University of Wisconsin-Madison. Here we're to go through and talk about some of the questions we get about profitable small grains production across the state. In any type of a system, the first thing we really have to focus on is variety selection. Part of the responsibility of my program is to run our Wisconsin winter wheat performance trials, and we post that annually on my webpage, which is www.coolbean.info. Here we can see the locations where we run our trials, and these are primarily the predominant winter wheat growing regions within the state. I know there's some up here in Wausau as well, but for the most part, we cover most of the state. Here are some of the data tables that we work with, and I really want to focus in on how we portray this data. So we provide farmers with a 4-test average, and these are aligned by company name. And we look at and focus primarily on yield and test weight. However, in a given year, if we have a disease problem, we are very fortunate to have Dr. Damon Smith's crew be able to come out and take disease ratings for us so we can post that relevant information for farmers and crop consultants to utilize in making their decisions for variety selection. You'll notice here we have what we call starred varieties. So these starred varieties are those varieties that are statistically similar to the highest yielding variety we have either within a location or across all of our locations put together. One of the other points we really want to make known is that we all know the crop rotation is important, but it's also the sequence of that rotation that is important here. So we're able to go in and look at some data from our long-term cropping system research trial held at Arlington, Wisconsin. And here we go looking at our corn, soybean, and wheat systems. And we'll focus here on which system is the most profitable, as in the highest yielding, I should say. So the highest yielding rotation for each crop would be the corn, soybean, wheat rotation. If you look here on the corn side of things, corn grown in this sequence is 11% higher than continuous corn and substantially higher than wheat grown after corn. On the soybean side of things, soybean grown in this cropping sequence, corn, soybean, wheat, is 26% higher than what we'd see for continuous soybean. Then in the wheat side of things, we have wheat grown in the corn, soybean, wheat rotation is 129% higher than that of continuous winter wheat. So the point I'm really trying to get across here is rotation is important, but also sequence. And here for Wisconsin, at least in this trial, the corn, soybean, wheat sequence is the highest yielding across all crops involved. I want to quickly walk through, talk about some different growth stages we have here. And here is the Feekes scale. And this is the primarily one that we'll see in herbicide and fungicide labels for making decisions in winter wheat. As we go through today, I'm going to focus on some specific growth stages and management functions that happen at each one of these different Feekes growth stages. So in any type of profitable system, we always, especially at small grains, we strongly recommend that farmers plant new seed each and every year. Plant certified or privately, professionally prepared seed that is true variety and has a high germ. We would make sure that you do not save seed from any field that had glyphosate used as a harvest aid, and also anti-fusarium head blight. But again, our main recommendation is plant new seed every single year. However, I know times are tough and sometimes the economics drive you to save your own seed and replant it. In that case, there's 4 quick steps to do. First of all, step 1, determine if you can legally plant wheat seed that you save. There's a lot of private varieties that have patents on them that do not allow you to legally save and replant that wheat seed. The next point to make is once you determine you can legally save it, clean that wheat seed. Next, perform a germination test, and then assess the need for a seed treatment. And you can find that in A3646, which is Pest Management in Wisconsin Field Crops. We do in Wisconsin recommend the farmers do use a fungicide seed treatment. If you're kind of curious about what that seed treatment package is, feel free to visit Dr. Damon Smith's What's on Your Seed publication, and you can go through and get an idea of what are the active ingredients used in any of these seed treatments that we see here in Wisconsin on either corn, soybean, or any of the small grains seed treatments. Well, in terms of our recommendation, we want to target our seeding rate for wheat planted between September 20th and October 1st at 1.75 million seeds per acre. Again, we did some work previously, and then we found, we used to have a recommendation of 1.5, and we saw an extra 2 bushels, a significant increase, moving from 1.5 to 1.75. Again, if a farmer and you can't buy that extra 250,000 seeds and cover that 2 bushel yield increase, then feel free to stick back with that 1.5 million seeds recommendation that we've had in the past. When we're looking at recommendations for seeding depth, we recommend that wheat should be planted between 1 and 1.5 inches deep, regardless of whatever planting date you have. And the reason for that is I know when we get delayed in planting, many times farmers will want to plant it in shallow just to get it out of the ground. And the challenge with that is if we're planting it at that shallow of a depth, we usually run into some issues related to tiller formation, as well as overwintering capacity. And here's a good example of that. I would say roughly 60% of the time, the challenges when I go in the spring and assess a wheat stand and it looks ugly is from too shallow of planting. So an agronomist, it's pretty easy to go out and determine that depth. You see here, this is where the seed carcass is right next to the crown. That seed was placed roughly 1/4 inch deep. We can see that we're lacking some tiller formation and overall growth and vigor of this plant. Here, you notice a structure called the subcrown internode. And you can measure the distance from that to the crown. We see that that seed was placed about 1 inch deep, which is the correct depth for planting. And with that, we can really see an improved vigor and growth of that plant. So again, regardless of whatever day you plant, strive to get that winter wheat seed in at least at least 1 inch in depth. Now, we recommend that farmers plant between September 20th and October 1st. And one of the things we can see here is that after roughly that September 20th, 25th planting date, we're losing roughly 1 bushel per acre per day for every day we're delayed it. Now, I always get questions around Halloween regarding, can I still plant wheat? The answer is yes, but you're really going to be struggling to achieve maximum yield potential at that point. And here we see with this data, we're losing roughly 25 bushels per acre by delaying our winter wheat from that last week in September to that last week in October. Now, one of the ways we're trying to get farmers in this crop sequence, the corn, soybean, winter wheat, and to get wheat planted on time is think about possibly planting some early maturity groups, soybeans that won't sacrifice any yield and will allow you to harvest that crop in a timely manner. So here, for example, this would have been data from 2020. We took all the early maturity group beans from our northern location, which would be Spooner, and planted them at Arlington, Wisconsin, which would be one of our southern locations. Typically, farmers in this area are planting around a 2.5 maturity group soybean. And in this case, we put maturities from a 0.4 all the way up to a 1.5. And we see very high yield capacity. All of these varieties yielded statistically the same to this pro harvest at 90 bushels per acre. So again, I think there is some potential there to plant some early beans and not sacrifice a significant amount of yield. Again, this is 1 year, 1 location. So I'm not telling farmers to go out and automatically put out a 0.4, but I think there are options here if we dig into this a little bit deeper to be able to get your soybean harvested early, not sacrifice any yield on the soybean side of things, and then be able to get your winter wheat planted on time or in a timely manner in order to get maximum wheat potential as well. So here's some data that we looked at when that plant in these early maturity group beans hit physiological maturity. So again, we see this 1.0 bean hit physiological maturity at September 11th. Roughly in a normal year, generally see the number of days between physiological maturity and combine ready to harvest is about 10 days. So this would estimate at a 1.0 bean, we would be able to go in, harvest right around September 26th, then as we generally see in Wisconsin, have the wheat planter right directly follow that combine across the field. So again, it just gives us some options in order to put those acres that we know are going into winter wheat, get them in a timely manner by planting an earlier maturity of soybean and not sacrifice much, if any, yield at all. Now, once we get beyond that October 1st, we ask growers to start incrementally increasing their seeding rate. So between October 1st, excuse me, and October 31st, we push growers to be pushing from that 1.75 million seeds per acre up to 2.2 million seeds per acre. And the rationale behind that is we're just not going to get the tiller formation on winter wheat that we require to maximize yield. So in order to effectively get more heads per unit area out there, the only way we can do that is increase our seeding rate. So again, just a recommendation that if we are planting later, increase that seeding rate to be able to get a higher effective head number out there in your winter wheat crop. Now, again, we usually get this question with some of our late planted wheat that right around Halloween or that first week in November is this wheat plant going to survive? Is it going to vernalize? And the quick and dirty answer to that is yes. Once that wheat seed starts the germination process, all it needs to do is imbibe water and start the germination process. That winter wheat will then vernalize and grow the following spring. So again, the short answer is yes, but again, we're going to be sacrificing a significant amount of yield if we're planting that late. I'm not going to talk a lot about this, but again, this is just our overwintering. We set that field up to maximize winter wheat yield. Now, what are the next steps forward in order to profitably grow winter wheat in Wisconsin? In the spring at Green Up, this is when we ask growers to go out and get a general overview of their fields. Look for any drowned out spots or dead spots. Look for winter survival. Do a plant count, if you will. Our recommendation for tearing up a field, somewhere in that 12 to 15 plants per square foot. So if there's less than that, 12 to 15, that's an automatic tear up of that field and replant to another crop. This is also the timing, according to some of the work Dr. Kerry Lebowski at University of Wisconsin-Madison has done, to consider your nitrogen application. So really put out your nitrogen at this green up phase for maximizing yield potential in winter wheat in Wisconsin. This is some table pulled out of A2009 that looks at the suggested nitrogen application rates. Again, since the crop sequence that we really want to focus on is corn, soybean, wheat, we look at soybean, or in this table right here, and then we look at the nitrogen to wheat price ratio. And wherever that may lie shows us what the recommended pounds of total N would be in that scenario. So here, if a nitrogen wheat price ratio of 0.075, the range to put out there would be between 40 and 60 pounds of N per acre following soybeans. So again, look this up, A2809, and helps you tailor what your nitrogen recommendations would be based on your soil type and your cropping sequence. I've introduced Feekes 6 growth stage to everyone here, just because this is the this is at this point is where broken stems will happen due to wheel track damage. This is usually the point 2 where we see many of the herbicides labels suggest that no application passes growth stage. So again, I just want to make this and point this out for farmers or applicators that be looking for this Feekes 6 in order to understand what the wheel track damage could be, is also looking for herbicide labels at this point. Feekes 9, this is when the flag leaf is emerged from the whorl and ligule is just visible. You can see that on this picture right here. This is usually the timing if we're looking for a foliar fungicide targeted for stripe rust or leaf rust, that timing would go out at Feekes 9. Now, for more information on fungicide application timings, I'll look at some of the information out there from Dr. David Smith at the UW-Madison for looking at products, rates, and timings at this Feekes 9. The last and probably important one in terms of management decisions would be Feekes 10.51. This is anthesis, or when flowering begins. If you look here on this wheat head, we see that anthesis or flowering are when these anthers are extruded from that wheat head. And we can see here in this image, and in all the time, I should rather say, that the wheat heads start flowering from the middle of the head and proceed up and down that spikelet. So again, this is a timing where we're going to be looking at making a fungicide application to target Fusarium head blight or scab. So I kind of want to take some of this work we've done recently into this intensive wheat management research that we've done. This has been published at the Agronomy Journal. You can click here in order to go see that, or we have an extension version of this posted on my website, which is www.coolbean.info. So how we looked at this is we kind of looked at management intensity, or in this case, 4 years of this experiment. So we have a current level of management, which is kind of just a base recommendation for farmers to look at. We have a mid-level where we start adding additional inputs, such as the higher seeding rate, a little bit of extra nitrogen, either split out, as well as a fungicide application targeted at Feekes 10.51 for Fusarium head scab. And then we have the high level, if you will, where we're really trying to push this crop for maximum yield. We'll put additional nitrogen out there. We're putting a growth regulator to help these plants stand. Given the high input costs, we're applying micronutrients. We're actually putting 2 different foliar fungicides out there, one at Feekes 9 and one at Feekes 10.51. And then we're also adding micronutrients into the mix. So again, it's really an intensive way of really trying to push yield and see if we can maximize yield and productivity across the landscape. So this slide here is a little fuzzy, but it really gets at the disease work that we did. And these, over the time frame of these experiments, we didn't have a tremendous amount of disease pressure, but a couple of points we would note is that those foliar applications of either Prosaro or Miravis really helped us out with some of the management of Fusarium head blight. So again, I just want to make that point that we did see some activity of those products. Now, it's a really busy slide. I apologize for that, but I really want to get at what's going on at the plot level as well as the management level. So when we're looking at this slide, again, we go by year. We have our current level, mid-level, or high level of management. We have all the varieties we tested over the 4 years of this experiment. So first thing I want to point out is look at the variability in yield, and that's why variety selection is extremely important when it comes to production of winter wheat. We see here, top to bottom, we see over a 30 bushel, or right around a 30 bushel, I should say, yield advantage just by a stud genetics alone. Then we target the management level by genetic interactions, and there's a lot to read in here, but I really want to point us down here at the bottom. And then we see in 2016, from going from the current to the mid-level, we saw a 6 bushel yield advantage, and then going to the high level in that year, we saw an additional 12. We don't always see that big of a response in a year, but in most years, or excuse me, all years, we did see a significant yield increase going from the current level to that mid-level, and in some years we did see a differentiation when we went to that high level of management. Now, in Wisconsin, yield is important, but test weight is as well. So if we look at this figure right here, we can see in terms of the test weight averages, we see a huge variation from 59.2 pound test weight all the way down to 54.3. So again, trying to balance this differentiation between high yield potential and test weight, because we want to maximize yield, but we also don't want to take dockage at the elevator. And another interesting point to note here is across most of these years, we did see a test weight advantage, i.e. an increased test weight going from our current level to our mid-level. Again, we didn't always see it going between the mid and high, but we always saw a bump in test weight when we went from the current to at least the mid-level. So again, balancing yield potential with test weight and using our management level to maximize both of our profitability and maximizing yield and our test weight. Now, one of the things we really want to take into play is sort out the economics of these systems. So here we talk about the frequency of price deductions, i.e. dockage by our different management levels. So in all of our cases, we ran these scenarios. So for no test weight deduction, under our current system, we did not get test weight 14%, no test weight deduction 14% of the time. When we moved to the mid and high level, we're right around that 37 to 43% of the time we saw no test weight deduction by implementing those management practices. The other thing I want to point out as we go down here is that this 10-cent test weight deduction. So roughly 51% of the time we saw a test weight deduction of at least 10 cents in a current system when compared to either our mid or our high level, which were right around 30%. Now, if we go down to no DON deduction, in the mid and current level, we saw roughly 100% of the time we did not see DON deduction. Now, again, this was not a tremendously bad scab years, at least at the locations we were at. But again, it just shows us how that management level can really reduce our dockage for both DON deduction as well as test weight. Whereas in the current system, 20% of the time, we did get at least some form of deduction based on our DON levels. And when we put all of these scenarios together, varieties, we really want to kind of dig down at what is the most profitable. And if we look based on profit of grain and straw produced, estimated cost of management, and the probability of deduction, the mid-level management was by far and away the most profitable system, where we saw $263.90 average profit in both grain and straw. And part of that is based on the fact that in both our mid-level production and high-level production, we saw about a half a ton greater straw production in that mid and high level. So in Wisconsin, obviously, grain is important, management for dockage is important, but the production of straw is tremendous. And there's a lot of value in Wisconsin in terms of our straw production and what that value is to the farmer as just bedding it alone or selling it outright. So again, I think if we look at this system here, this mid-level management is a good opportunity for farmers to maximize straw production and maximize profitability. For more information on winter wheat production, please go to my website, which is www.coolbean.info. You can follow me on Twitter @BadgerBean. And for any information of things going on in season, follow me on the soyreport.blogspot.com. Thank you for your time and have a great day.